my dear students, welcome to Deeksha Karnataka YouTube channel and welcome to another chapter of your PU2 preparation. So dual nature of radiation and matter, that is I am going to discuss in today's Brahmastra. So don't miss out, this is a completely revamped blueprint. So let us first, obviously we will look into the blueprint of this chapter. So if you look into the blueprint of this chapter, there will be two 1 marker questions. That means 1 marker questions, one of them will be MCQ and one will be fill in the blanks according to the 3 model paper shared. So that is the expected question. Also there is no 5 marker, no 2 marker question, only one 3 marker question is going to come from this chapter. So total 5 marks will be allotted for this chapter. This is an easy chapter. If you study a few questions and practice a few MCQs, then definitely you should be able to answer all the questions from this chapter. So what we are going to discuss in today's session, we are going to discuss MCQs 15, we will also discuss fill in the blanks 5, also we will be discussing 7 3 marker questions including your latest model question paper questions. So let us start. First question. In a photoelectric experiment, the graph related to two quantities is a straight line with the slope equals to h by e. Then it is a graph of, very interesting. So how do we know this is a graph, which quantity is graph, and how to determine the slope? If we can write the equation like this, then we know that this represents the slope and C represents the intersection, right? That is the equation of a straight line. So equation of a straight line, if we can write it like this, then we can find the slope as well as the intersection. So here they are asking about the slope. So first, obviously one equation that comes to our mind from this chapter is the Einstein's equation, which says that K max actually equals to the energy of the photon that is supplied minus the work function. This is the standard equation. Now this K max can be related to in terms of stopping potential, it can be written as EV0, where V0 is the stopping potential. K max, or the maximum kinetic energy of the electron that is coming out during a photoelectric emission, is given by EV0, right? So from there we can write EV0 equals to h nu minus phi naught, or V0 equals to h upon e into nu minus phi by e. Okay, so if you see that if this quantity is represented by y, if this quantity is represented by x, then we can say that this is our slope and this is our intercept along with the sign. Okay, so this is y equals to mx plus c, minus c equals to minus phi by e. Okay, so from here we can say that the slope is basically stopping potential versus frequency of the radiation. Okay, stopping potential versus frequency of incident light. So correct answer is option C. Very careful, in case you forget, start from here and try to configure the equation so that you don't miss out on the correct answer. This is very, very important. Okay, and this question is there in your model question paper as well as in your question bank that is shared by the board. So this question can be very important, not only during your pre-board but also for your final board exam. In photoelectric effect experiment, if only the frequency of incident radiation is increased, then the maximum kinetic energy of the photoelectron decreases, the stopping potential increases, the photoelectric current increases, the photoelectric current decreases. Now here you have to remember one thing, is that if you increase the frequency of the incident radiation, the maximum kinetic energy will increase, right? Again the same equation, K max or maximum kinetic energy is given by h nu minus phi. Now phi is a constant, so if you increase the frequency, then K max should also increase, right? But here they are saying that maximum kinetic energy decreases, so definitely this is not correct. Decreases is not correct, it should increase. Secondly, stopping potential increases. So if K max is increasing, we know that K max is given by EV0. So if K max increases, V0 should increase. E is a constant. right? So if frequency increases, Kmax increases. If Kmax increases, stopping potential increases. So this is the correct statement, because it is a stopping potential is getting increased. So that is the correct statement from this statement. Now, photoelectric current is independent of the frequency. It depends only on the intensity. Saturation current or maximum photoelectric current, it is independent of the frequency. It only depends that the frequency has to be more than the threshold frequency. If that condition is satisfied, then definitely photoelectric current is independent of the frequency. It only depends on the intensity. Okay, clear? Now let's move on. The de Broglie wavelength of a moving particle is independent of dash of the particle: charge, mass, speed, momentum. Now de Broglie wavelength is given by what? Lambda equals to h upon p, where p is momentum, or h by mv. So definitely lambda depends on momentum, lambda depends on mass, lambda depends on velocity as well, but there is no mention of charge. So definitely it is independent of charge. De Broglie wavelength is independent of charge. Next, the process of emission of electrons from a metal surface by applying high electric field. By applying high electric field is called field emission, as the name suggests. So remember, high electric field or electric field emission due to electric field is called field emission. By heat is called thermoionic emission. Okay, and by light is called photoelectric emission. Okay, secondary emission is not important. So these three emissions are there in your textbook, so you should remember: due to heat, thermoionic; due to field emission; and due to light, it will be photoelectric emission. In photoelectric effect experiment, the graph of a physical quantity y versus a physical quantity x is a straight line passing through the origin. So in photoelectric effect, this is a graph that they are talking about, y versus x. Okay, so what is this graph represents? Definitely this represents the photoelectric current, and this represents the intensity of the light. Okay, so it is a photoelectric current and x is intensity of incidence. So y is photoelectric current, x is intensity of incident radiation. In only this case, the graph will be a straight line passing through the origin. Okay, now let's move on. Macroscopic particle in our daily life do not show wave-like properties because they are not associated with waves. Their wave is extremely high, their wavelength is 0, their wavelength is negligibly small. So in this case, the correct answer is the wavelength is negligibly small. Okay, so we know that wavelength is given by h by lambda, h by p. So for us, even if you can increase the velocity or mass or whatever it is, the problem is this h. H's order is of the order of 10 to the power of minus 34. Right, that is the Planck's constant. So that's why what happens, no matter whatever you do, okay, you cannot have a very high wavelength. Wavelength high is possible only when the mass is very, very small, so that they can cancel, right? So that's why you cannot have a very high wavelength, and wavelength is not 0, by the way. Even though it's small, it is not 0, it has a physical value. So that's why you have to write negligibly small. Next question. Wavelength of matter wave is known as Einstein's wavelength, threshold wavelength, de Broglie wavelength. We all know that the wavelength of matter wave is called de Broglie wavelength. Photoelectric emission emitting electrons applying heat, electric field, magnetic field, light. So photoelectric emission happens due to the emission of light. Next, according to de Broglie, the material particle exhibits wave nature only at rest, only in motion, only when kept at a rest in magnetic field, only when kept at a rest in electric field. So electric field and magnetic field has nothing to do with de Broglie wavelength. Again, the same formula, lambda equals to h by mv, that is, it has to be in motion. If it is not in motion, then we will not get any wavelength. So that means it only in motion we observe de Broglie wavelength. photoelectric effect was discovered first or observed by Einstein, Hallwach, Leonard or Hertz? It was Heinrich Hertz. Heinrich Hertz, the same person on which the unit of frequency is named. Okay, Heinrich Hertz is the person who first observed the photoelectric effect. Minimum frequency required for photoelectric effect is minima, threshold frequency, Einstein's frequency, de Broglie frequency. Interesting question. It is called threshold frequency. The minimum frequency required for a photoelectric effect to take place is called threshold frequency. Einstein's photoelectric equation is in accordance with conservation of mass only, conservation of charge only, conservation of energy, conservation of momentum. So Einstein's photoelectric effect is only based on conservation of energy. Okay, conservation of energy, Kmax equals to h nu minus phi naught. That is, Kmax is the energy, h nu is the energy of photon, and phi is the minimum energy required to liberate one electron, right? So from there it's an energy equation, and we can say this is based on conservation of energy. In photoelectric experiment, if both the intensity and frequency of the incident light are doubled, then the saturation photoelectric current is doubled, remains constant, becomes 4 times, is halved. So photoelectric experiment, intensity and frequency both are doubled. Now we know that the saturation current is directly proportional. So saturation current is directly proportional to the intensity, right? Directly proportional. So, and there is no relationship with frequency. So if it is doubled, if intensity is doubled, then saturation current will also be doubled. It will not be 4 times because both of them are increasing. Saturation current is independent of the frequency, so that means only it will be doubled and not quadrupled or not remain same. If only frequency is doubled, intensity remains same, then it will remain same. Okay, because the intensity is getting doubled and they are direct proportional relationship, that means current will also be doubled. Very interesting question. The maximum kinetic energy of the photoelectrons depends only on incident angle, potential, pressure, frequency. So maximum kinetic energy depends only on frequency. It does not depend on anything else. Okay, Kmax equals to h nu minus phi. So Kmax depends on frequency of incident wave, that is nu. That's why it depends only on frequency. Light of certain frequency and intensity incident on a photosensitive material causes photoelectric effect. The incident radiation made exceedingly dim. Okay, so we have a photosensitive material. Some incident light is falling on this. Suppose initially we had a lot of bright light falling on this, and we are getting some electrons out of this surface. Okay, that is called photoelectric effect. In photoelectric effect, light is falling on a surface, and in return we are getting some electrons out of the surface. Now what happens is that suppose you make the source exceedingly dim. That means you decrease the intensity of the light. Then what will happen? Photoemission will cease to exist. Will the photoemission will cease to exist? It does not depend on the intensity of light. Photoemission will still take place. Saturation current might change, but photoelectric effect will not cease. Even if the light is very dim, it will still continue. Photoemission will continue, but saturation current will decrease. Yes, this is the correct statement. Photoemission will continue, but saturation current, which is proportional to intensity, that's why intensity decreasing means saturation current will decrease, but the photoelectric effect will not cease to exist. Cease to exist means it stops, but it is not happening. Okay, so be careful about certain language. Other options, photoemission will continue, but saturation current will increase. Saturation current cannot increase because you are decreasing the intensity. None of the above is obviously not the answer. Now let's move on to the fill in the blanks question. In interaction with matter, light behaves as if it is made up of packet of energy. Okay, in interaction with matter, light behaves as if it is made up of packet of energy called. So what is the name for packet of energy? It is called frequency, wave, intensity, particle, photon, zero. So it is known as photon. From the given option, this must be the term photon. the charge of a photon is, photon is a uncharged particle. It can be considered as an uncharged particle in motion, so charge of a photon is 0. Next, maximum kinetic energy of a photoelectron depends only on the dash of the incident radiation. So the maximum kinetic energy depends on frequency. 0 is also done. So maximum kinetic energy depends only on frequency. Again, the same equation, K max equals to h nu minus phi. So from here we can say that maximum kinetic energy depends on, in some cases we write phi naught. Okay, so this is called the incident radiation. That means this is the frequency. The answer will be frequency in this case. The saturation current in photo emission depends on the dash of the incident radiation. Saturation current depends on the intensity. Saturation current depends on the intensity of the incident radiation. So correct answer is intensity. A fast moving electron will behave as a wave. A fast moving electron will behave as a wave. Okay, so correct answer is wave. Now let's move on to the 3-marker section. There is no 2-marker question going to come from this chapter, only 3-marker question, no 5-marker numerical. Like last year there was a chance from this chapter, there was a small possibility of 5-marker numerical, but that did not came. But this year according to the blueprint, there will be no 5-marker question, only 3-marker 1 question will come, and we will practice all the questions that is going to come from this chapter. Give Einstein's explanation of photoelectric effect and write Einstein's photoelectric equation. Okay, Einstein suggested that each photon of light has energy proportional to frequency nu given by E equals to h nu, where h is Planck's constant. When light shines on a metal surface, photons transfer their energy to electrons in the metal. Okay, any energy from the photoelectron exceeding the work function becomes the kinetic energy of the ejected electron. So now this is first part. Write Einstein's photoelectric emission we will see in another question, don't worry. Okay, give any 3 results of experimental study by photoelectric effect, or same question might come, write the experimental observation by Hallwach and Leonard. Okay, Hallwach and Leonard's observation, same question, only thing is the name is different. Okay, Hallwach Leonard's observation or any observation of photoelectric effect, same question. For a given metal, no electrons are emitted if the frequency of the incident light is below a certain minimum value called threshold frequency. Very important. Okay, regardless of the intensity of light. Photoelectric emission occurs without any noticeable delay, so it basically happens in the time 10 to the power of minus 9 second delay. There is a delay, but delay is 10 to the power of minus 9 second, which is almost negligible. Okay, after the light strikes the surface, even for a very low intensity. Okay, so as soon as the light strikes the surface, we get 1 electron out of the surface. That is basically photoelectric effect. The maximum kinetic energy of the emitted electrons increases linearly with the frequency, the incident light above the threshold frequency. Okay, so the maximum kinetic energy of the emitted electron is increasing linearly. Okay, the maximum kinetic energy increases linearly with the frequency. Okay, this is K max and this is the frequency. This is the cutoff frequency nu naught. Okay, the intersect, otherwise this is a straight line. Right, now let's move on. What is meant by photoelectric effect? Defined work function, defined threshold frequency. This is also very popular question. The photoelectric effect refers to the phenomenon where electrons are emitted from the surface of a metal when light of a certain frequency or higher shines on it. These emitted electrons are called photoelectrons. Next, the work function. The work function phi is the minimum energy required to eject an electron from the surface of a metal. It is property of the metal and is typically measured in electron volt. Okay, work function also depends on temperature. Next, the threshold frequency nu naught is the minimum frequency of the incident light required to cause the emission of electrons from the surface of the metal. For light with frequency below nu naught, no electrons are emitted regardless of the light intensity. Okay, so this is called threshold frequency. Threshold frequency is the minimum frequency and work function is the minimum energy required. Okay, so they are related to each other but not exactly, there is a small conversion that work function is actually given by h nu naught. Okay, that's how they are related. In case you want to remember it, that is how they are related. Now mention Einstein's photoelectric emission and explain the symbols. The same question was asked in that part, so I skipped it because I have covered it in a separate equation. This is the Einstein's photoelectric emission, where h nu is the energy of the emitted light. Okay, this is the energy of light. This is the energy of light. And phi is the work function, and half mv squared is the kinetic energy of electron. Okay, h is Planck's constant, 6.626 into 10 to the power of minus 34. You can assume this 6.63, that is also fine. Nu is the frequency of incident light, phi is the work function of the metal, m is the mass of electron, 9.11 into 10 to the power of minus 31. V is the velocity of ejected electron. Okay, if you don't want to write half mv square, you can write k max as well. Okay, or the equation that I was writing, that also fine. K max equals to h nu minus phi naught, that is also fine, but you have to explain the terms very clearly. Now next, the work function of cesium is 2.14 electron volt. Calculate the threshold frequency for cesium. How to calculate? So work function of cesium is given by, so work function means phi or phi naught, that is given by 2.14, and they ask you calculate the threshold frequency. So what is the relationship between threshold frequency and work function? This is basically simply h nu naught equals to 2.14 EV. Now EV to joule, you have to convert EV to joules first. So 1 EV is basically 1.6 into 10 to the power of minus 19 joules. Anything familiar with this? What is this? This is the charge of an electron. Okay, only thing, if you multiply with 1 volt and 1 charge of an electron, you get 1 electron volt. Okay, and because it saves us some space for smaller energy, we use EV. Okay, so here in this particular case we have to convert it into joules, so we have to multiply with 10 to the power of minus 1.6 into 10 to the power minus 9. So what is the threshold frequency? Threshold frequency is 2.14 into 1.6 into 10 to the power of minus 19 divided by 6.63 into 10 to the power of minus 34. Okay, if you calculate this approximately using a calculator, you will get 0.52 into 10 to the power of minus 10 to the power of not minus plus 15. Okay, plus 15. And what is this? This is a frequency. So what will be the unit of frequency? Unit of frequency will be hertz. Same person hertz. So you can write it as this as 5.2. You can leave the answer over here, or if you don't want to keep it as a decimal number, 5.2 into 10 to the power of 14 hertz. Anyway, it is correct. Okay. Easy question. Only thing you need to know is how to convert from electron volt to joules, and then the Planck's constant value, which are very, very standard values. Now let's move on. Write any 3 properties of photon. These questions are last question, this question and next question are from your model paper. Any 3 properties of photon are: photon has 0 rest mass and always travels with the speed of light in vacuum. Okay, so this is photon. Even though it is a photon, it is traveling at a very high speed, the same speed of light. A photon carries the energy E equals to h nu and momentum p equals to h by lambda. Okay, a photon is electrically neutral and is not deflected by any electric or magnetic fields. Okay, so these are the three properties of photon. All of them are very, very important. Don't forget them. It also came one time in a previous year paper as well. So you have to prepare this question as well. What are matter waves? Explain the de Broglie hypothesis of matter waves. So matter waves are the waves associated with the moving material particles such as electrons, photons, atoms, etc. De Broglie hypothesis. Now de Broglie hypothesis, Louis de Broglie proposed that every moving particle behaves like a wave. So matter wave means wave associated with moving particles, and de Broglie suggested every moving particle will have their own wavelength. Okay, just as light shows particle nature. Because why he assumed it? Because he thought nature likes symmetry. Okay, most of the natural things are symmetrical. For example, we have right hand, we have left hand. So even if you look it from like this, we are symmetrical on both sides. So that is one thing to consider. Okay, if you consider our brain also, it is symmetrical on left and right lobe. There are two lobes. So most of us are symmetrical in nature, and that's why de Broglie proposed that when this entire photoelectric saga was going on, Einstein's explanation etc. was going on, he suggested that nature likes symmetry, and that's why if light can behave like a particle, then particles will also behave like a wave. That was his point. That's why it is called hypothesis. Later on, Deeksha and Jarmer did an experiment and proved this hypothesis. It is no longer a hypothesis, this is a theory now. But anyway, when he gave this is called hypothesis, because like Avogadro number, okay, Avogadro's hypothesis. Now it is Avogadro's theory, right? When Avogadro gave it the exact number 6.623 into 10 to the power of 23, people thought, okay, this cannot ever be proven, but it was later proved. Similarly, here de Broglie hypothesis initially was given as a hypothesis, later on it was also proven. Okay, so his idea was, because light is behaving like a particle will also behave like a wave. Okay, according to him, any particle of momentum p has an associated wavelength lambda called the de Broglie wavelength. Because he gave the theory, the wavelength is called de Broglie wavelength, and the value is very simple, lambda equals to h by p, where lambda is the de Broglie wavelength, h is Planck's constant, p equals to mv equals to momentum of the particle. Clear? So this is it. So I hope you understand and enjoyed the session, right? So if you like this session, don't forget to subscribe to our channel and join the WhatsApp channel if you want the PDF of this lecture. The PDF of this lecture along with all the Brahmastra lectures that we have done are shared in our WhatsApp channel. So don't forget to join the WhatsApp channel. Also share this video with your friends so that they can also learn and understand this concept of these chapters and score 5 marks. Right? I'll be back with a new chapter very soon. Till then, bye.